Hello, can you hear me?
Hello, how's it going?
Yep, we can hear
Sorry I'm
you.
late. I was in another meeting that ran overtime. So I got held up in another meeting. It took me a little while to get out of it. Yeah. So let's see. Everyone's joining. Looks like everyone's coming in. Okay. Okay. So to get started, I'm going to switch to sharing my desktop like we did last time. And I'm going to go to the course website and start talking about what we're going to do today. So let me start sharing my desktop. Okay, you should see my desktop now. Is that right? Does it look okay?
Yep, we can see it.
Okay, and I want to look at the, I forgot, where is the pop-up for the chat? Where is that in the I'm not finding it.
It should be next to participants.
Yeah, and it's not. I got, yeah. Huh.
Different dynamic when you're screen sharing.
Probably, yeah.
Oh, I think it's like on the top screen maybe.
Under more. Oh, it's under more. It shows up under more. Yeah. Okay. So I got it now. Okay. It shows up under more instead of being on the main taskbar. Okay. So let's see now. Okay. I'm going to go to the course website. And let's see, we're in the Monday, Wednesday class. So we're going to start talking about what the textbook has about chapter 2. Well, first, actually, okay, so now here's the entry for today. Yeah, the entry for today is that there's a reading assignment for next Monday. So that's switching to the other textbook. It's the same material that was in chapter 2 of this text. So here, if I show you, chapter 2 of this textbook is called Variables. And the reading assignment from this other textbook is called Variables. So we're going to be talking about variables for a while. Okay, so these are two different ways of explaining the idea of variables. So I think they're two good readings about variables. So we're going to be talking today about chapter 2 of one of the textbooks, and we'll start to, so we're going to talk about variables. So now, first, does anybody have any questions about what we did on Monday or about the homework assignment that's due on Monday? Anybody have any questions so far?
I do.
Have you fixed the uploading problem?
Oh, I forgot about that. I created an upload link in the course, but I forgot.
Class.
Yeah, there is a thing for you to upload homeworks, but I forgot to update this. This page is still missing. Yes, that page is still missing. I gotta fix that. But in Brightspace, there is a place for you to submit your homework. It's under assignments. Is that where it is, or something? I know some of you have used it already. Some of you have already turned in the homework. I'll try to get the instructions up there later today. But you can also just go into Brightspace and play around. You might find it in Brightspace. So there is a place in Brightspace for you to upload the homework assignment, but I have not put the instruction page up there yet. Okay.
Could you also go over how the heading is supposed to be on the homework?
Oh, that's right, because that was in that page. Was just let me get the homework. Mimic the screenshot that's in here. Just mimic that. Yeah, you can't copy and paste because that's a screenshot. Just mimic that. The CS123, your name, your email address, assignment 1, and see it goes between. And oh, actually, I gave you the place to where to put it. So here's the homework assignment. Just put that in here. See, just between the stars there. So you just put.
The thing that was in, what was it? It was in the grading criteria. I went to there and it said like the homework assignment, like at author and at version. And I was like, that doesn't seem right.
No, you don't need all that. Yeah, you can just type, actually, all I really need is your name and your email address. the most basic information to make sure you put in there is your name and the email address. And then if you want, you could put the course number and the assignment number. Okay, so just put those between these up right here. Put them right in there. Just put it in there. Okay, using Dr. Java. Okay, I don't have Dr. Java yet on this machine. Okay. Okay, so
Okay,
that.
thank you.
Okay.
One quick question, Professor.
Mhm.
JDK 11, were we able to fix that? For the homework assignment, I have to download JDK 8.
Yes.
in order-
Yeah. I rewrote the instructions. I thought Dr. Java was compatible with Java 11 by now. It still isn't. So
Okay.
I rewrote these instructions to basically just say use Java 8.
I see.
So we're going to be using Java. Dr. Java simply does not work with anything after Java 8. And I'm not sure if they're going to change that or not. So it doesn't really matter from our point of view of what we're doing in this course. The difference between Java 8 and Java 11 are only in the really advanced features. It doesn't affect the introduction to the language. But Dr. Java doesn't work with Java 11. So I rewrote everything here to work with Java 8. Okay.
Perfect.
And yeah, if anybody, so yeah, that's important. Yeah, I rewrote the instructions. We're going to be using Java. Actually, I should change it right here. Yeah, I should change it here to say Java 8 also, right there. Forgot to change that. Okay, so we're going to be using Java 8. Okay, and if you run into any difficulties trying to get Java installed, send me an email. Okay.
Professor,
Mm-hmm.
I'm using IntelliJ. I'm just more familiar with it. Is it like the same concept when we upload the homework? We just take a picture of the console?
Yeah. Well, what
We just take a picture of the code in the console, right? And then we send like the homework file too.
Yeah. Yeah. You definitely send the Java file. And
Okay.
I can't. Does IntelliJ show the console in the same GUI as the code editor?
Yes, it does.
Yeah. Just take a screenshot of me. Here's. You're using IntelliJ.
Yeah.
Oh, I forgot to activate this thing. So
Yeah, no, it's fine. It shows it in the same window. So
okay. Yeah. Yeah. I use IntelliJ only every once in a while, so I'm not a big user of it. So I have it on this machine, but actually I haven't even activated it yet.
okay, thank you.
But yeah, just you should be able to take a screenshot of the code and the output at the same time, and that'd be fine. Okay. Let's see. Other questions about the homework or about what we talked about on Monday? Okay. All right. So all right. So what we want to do is start talking about the notion of what are variables in programming languages. Okay. Now, actually, let me get set up with Dr. Java. I have Dr. Java like you do. I have it on my C drive, and I'm just going to create a shortcut to it on my desktop. So I'm just going to create a shortcut to Dr. Java on my desktop. Okay. Right. Now, I'm just going to type some stuff that's not Java. You're used to the idea of variables like in a math class. And in a math class, you might type like a famous formula like y equals mx plus b. Okay, the famous equation of a line. Okay, y equals mx plus b. Okay. Now, these letters are what we call variables. In this equation, in a math class, the m and the b aren't the same as the y and the x. They're different kinds of variables. Normally, you would say something like the slope is 2 and the y-intercept is 3. Okay. Yeah. So you would give values to the variables like m and b, but you don't give a value to m and to x and y. When you look at this equation, it's saying that for any x, the y is m times the x plus the b. Okay, so then you would graph that as an equation, that you graph that as the equation of a line. Okay, and Google can even do that for you. If I go over here to Google, Google, if I say something like 5x plus 3, see, Google draws the line for me. Okay, that 5 is the m, 3 is the b, and x represents all these numbers between negative 14 and 14. There's the x-axis. Okay, now programming languages have variables just like math has variables, but the programming languages variables are like the a and the b, not like the y and the x. A language like Java doesn't have something like y and x. What I mean by that is, in a language like Java, every time you have a variable, it has to hold a number. There is nothing like the x in here, where x just represents all these values from negative 14 to 14. Java doesn't have an algebra variable like this x. Okay, so let me switch to Java now. Okay, so like when I'm typing there, I'm going to make that a comment. Okay, so that's a comment. Now, if I want to make a Java program, I start off by saying class variables. I want to play around with variables, okay? And then I'm going to create a main method. Okay, I create a main method. Okay, I'll put some code in there in a minute. Okay, so here's my outline of a program. I need to save it before I do anything with it. So I'm going to save it on my desktop. I'm going to save it on my desktop. Call variables. Okay. What happens if I run this program? I can compile it. What happens if I run it? What do you think will happen if I run it?
Nothing.
Nothing. Yeah, I haven't told it to do anything. In here is the stuff where you tell it what to do. So if I say run, just nothing happens down there. See, it ran it, but nothing happened. To make something happen, I might do system.out.println. Now I've told it to do something. So now if I compile it and run it, see, now it printed out the hello. Okay, it printed out the hello. Oh, I forgot the little, notice how I printed out, notice I wrote print, not print line. Notice that it printed hello, and then the little arrow is right next to the hello. That's because I didn't say and print a line with hello on it. So that there's no thing that makes this a new line at the end here. Now watch what happens if I change this and put a little ln there, put the ln right there. Now recompile, run. See how the arrow appeared below the hello now. Okay, so now I got a program that does something. Okay, now I want to start talking about variables in a program. Okay, in Java, if I want a variable, I have to tell Java that I want to use a variable. For example, I can't do the following. I can't say x equals 3. If I say I want a variable named x and I want it to be 3, Java complained here. Okay, cannot find symbol variable x. What it means is I never told Java that I want to use a variable named x. We use the phrase you have to declare a variable before you use it. So I need to declare my variable. So here's what it looks like. I have to declare it by saying int x. The int is something called a declaration. It's saying that I'm going to have a variable named x, and it holds an integer. Now, if I compile, this thing worked. Okay, I'm not doing anything yet with that variable except putting the number 3 in it. Notice that if I do this, now I'm going to get a compiler error message because I said I have an integer variable, but I put a decimal number in it. Java and most programming languages make a distinction between integer numbers and decimal numbers, okay? If I want to hold a decimal number, I change the declaration. I'll show you. So there's my integer number. Decimal numbers, for a strange reason, are called doubles. So I'm declaring a double. I have to use a different name now because I can't have two variables named x. I'll call it y. Here's 3.5. Okay. So now I've got two variables, x and y. One is an integer and one is a decimal number. Now, if I run it, I'm not doing anything with x and y. If I want to do something with them, I could, for example, system.out.print line. I could print I'll add them up. I'm going to print x plus y. Compile. Notice every time I make a change, I have to compile, then run. And look, I got the number 6.5 because I took the number 3 and added it to the number 3.5. So here I did something with the variables. Okay. Programming involves, surprisingly enough, almost everything about programming is creating variables to hold data, manipulating the data, and printing out results. You know, we'll see as we go along that variables are, just like in mathematics, the variables are the heart of math, they're also the heart of programming. But unlike math, where you have these variables like y and x, like I showed you, like where x just represents any number on the number line, in programming, the variables are like b and m. They always represent specific values. X has to have a value in it. There is no, like here let me give you an example. Suppose I say int z, okay, and I say system.out.print z. Okay, now I declared the variable, which is okay, but I didn't put any value in it. And Java complains. Now notice it didn't complain about line 16. I told Java I'm going to use a variable z. That's okay. But then when I tried to print it, Java complained, but you didn't give me a value for z. Okay, z might not have been initialized. There is no notion of a variable that doesn't hold a value in Java. Unlike up in algebra, where you can talk about y and x just being x meaning a variable that represents any real number, I can't say that this represents any integer. I have to actually tell Java what integer it is. So for example, I could now say, oh, I want it to be 0. Now Java's happy. Now I can compile it and I can run it and it'll print 0. And if I want, I can also do this. I could declare the variable, and then after I declare it, say it's 0. This is actually, from Java's point of view, slightly different. 16 declares the variable, 17 gives it a value, so I can do it in 2 lines. Java's happy with that. Okay. All right. So in a programming language like Java, every time you want to have a variable, you have to declare it. And you have to declare what kind of variable it is. Like x only can hold ints, y only can hold doubles. So you have to declare the variable and declare what it is. There are other programming languages that work differently than this. Like a famous language called Python doesn't require that you declare variables. In a language like Python, you can just do that. That's perfectly okay. Just say x is 3. And Python will say, okay, you have a variable now. You now have a variable named x that holds the value 3. Python doesn't require that you declare a variable, but Java does, okay? And then once you declare a variable, it can only hold that kind of value. So I can't come down here and say that x is 1.5, okay? That won't work because I said x is an int, so I can only put integers, whole numbers into x. I can't put decimal or fractional numbers into X. Once I tell Java what kind of variable X is, it has to stay that way. Okay. You can't erase a variable. You can't here's a good example. You cannot redeclare X. Suppose I want to switch X from int to double. You'd think that might be okay. Java won't let you do that. X is already defined. See down here. You can't redeclare a variable. Once a variable is declared, it's kind of stuck. You know, X is an int and it has to stay in it. It can't change to something else. Okay? So these are very picky rules. Not all languages have these picky rules. Java is famous. Java and C and C++ are famous for having very precise rules about what you can do with variables. Python is a language that's very famous for not having very many rules. In Python, you can actually just you can just use a variable without declaring it. Sometimes the variable can hold integers, sometimes it can hold doubles. You can pretty much do anything you want in the Python language with your variables. Some people like that. There are disadvantages to that. Someday you'll learn, when you learn more about computer science, you'll learn like why would Python want it one way? Why would Java want it a different way? And the answer is because each way has its advantages and its disadvantages. The Java way has advantages and the Python way has advantages. And they both have disadvantages. The Java way is to be picky, lots of rules. You have to declare a variable before you use it. Once you declared a variable of a certain type, we call this the type of the variable stays that type. And then once the variable has a certain type, you can't put other kinds of values into it. You can only put whole numbers in integer variables. Now, one thing that's interesting is y is a double. Suppose I put 5 into y. Well, I forgot the semicolon. Okay, notice that 5 is a whole number, but y is supposed to be a decimal number. So what happened there? Why did Java say that's okay? Y is supposed to be a decimal number, but I put a whole number in it. Well, let's print it out. Let's go ahead and print out y, see what's in it. So compile it. What did I do wrong? Oh, I got 2 little parentheses there. I'm sorry, I got 2 parentheses there. Notice how when you're typing, it's real easy to make little mistakes and you keep getting, you get error messages and like I didn't see that I had 2 parentheses there. A little bit hard to see that there were 2 parentheses there. So I had an extra parentheses, so fix that. Okay, now what is in y? I told that y is 5. If I run it, down here you see that y really holds 5.0. Okay. In Java, if y is meant to be a double and you put a whole number in it, Java adds the decimal point. It's a minor issue, but it really means that it isn't 5 that's in y. Y doesn't hold the integer 5. Y holds the decimal number 5.0. Okay. So now Java will not convert a decimal number to an integer, but it will convert an integer to a decimal number. So it converts an integer to a decimal number, but it won't do the other way around. Okay, so if I go back here and I say x equals 1.5, that's trying to put a decimal number in an integer. Let's look real carefully at the error message. Incompatible types. The right-hand side is a decimal, the left-hand side is an integer. That's incompatible. Possible lossy conversion. Now, what do they mean by that? If Java was really going to force this number into that integer, how do you think it would try to do it? What would be the reasonable way to force that number into that integer?
It would either round down or round up.
Yeah, it would either round, but then you would lose information. See, so that's what they're telling you. It would have to either round it up or round it down, but then you've lost the information that the number was 1.5. So that's what they're saying, possible lossy conversion. Java doesn't want to throw away information. If the value is 1.5, it doesn't want to round unless you tell it to. Later on, we'll learn how to do the rounding. You can round 1.5 up or you can round it down, but you have to tell Java which way you want to do that. Okay, so we'll see that, for example, actually, here's how I round down. I say, this is a real funny thing to write, but this saying, take the number 1.5 and truncate it to an int. And if I compile this, Java's happy, because now I've told it to round 1.5 down to 1, but I told it to do that. So now x holds 1. Okay, so Java is real picky about this stuff. It will not convert a decimal to an int, but it will convert an int. Now, why is it okay to convert an int to a decimal? Like, why do you think Java just is willing to do that?
Because you don't lose anything.
Yeah, you don't lose anything. You're adding a decimal point, 0.0. So from Java's point of view, it hasn't had to throw away any information. It's actually adding a little bit. It just put a 0.0 at the end of the number. So Java takes the point of view that it will not throw away information, but it'll add a 0.0. And that's real important because not all languages work this way. Some languages will throw away the 0.5. So if you assign a decimal number to an integer, the language will throw away some of the information, which actually can be the source of a bug in a program if you're not careful. So Java is very careful. It never wants to throw away information. So you get compiler errors like that, and you can see possible lossy conversion. Okay. Now notice that the reason it says possible, because think about this. What if it dropped the 0.0? What if, should Java take 1.0 and put it into X? Is any information being lost? What do you think? So,
Technically, some information is being lost.
Say again?
Technically, yes, there is some information being lost.
Kind of, but not much, right? Because what are you going to be converted from? 1.0 to 1?
To 1.
1. So there's really, see, that's why they say possible loss. Because if the right-hand side is 1.0, you're really not losing anything, but Java still refuses to do it. But they notice the error message is actually kind of precise. There's a possible loss of, because not always the case. 1.0 being converted to 1 is not really a loss of any information, but it still refuses to do it. But 1.2 converted to 1 is a loss of information. You're losing the 0.2. So when you try to convert a decimal number to an integer, Java says, well, you might be losing information, so I refuse to do it. Now, it's not saying you are losing information because there's the special case of converting 1.0 to 1, which technically is not really a loss of information, but yeah, it's still converting it from a double to an integer, but Java refuses to do it, okay? So from the point of view of Java, 1.0 and 1 are not the same thing. Yeah. So 1.0 and 1 are not the same. So Java's not gonna convert 1.0 to 1. Okay, it still refuses to do that. It won't make that conversion. Okay. Now, how many different kinds of variables are there in Java? There's actually, I think the answer is 9 different kinds of variables. For now, we're going to use 3 kinds of variables. We're going to use integers, doubles, and we're going to use another kind of variable called a string. String S are variables that are strings. They're things between double quotes. Okay, so for example, hello, that that is a string. The characters between double quotes are a string. So Java will, oh, I have to get written out. I'm gonna comment that out. I don't want to erase it because I want you to, to see that there's an idea there that 1.0 and 1 aren't the same thing. So I'll leave that in the program, but I'll comment it out so Java doesn't care about it. Okay, so now Java ignores that line. Okay, so this is my third kind of variable. I have integer variables, double variables, and string variables. Okay, now there's a slight difference between this and this. This prints out hello. This prints S, but what does S hold? See,
Hello.
S is a name for hello. So in a sense, 24 and 25 seem to be the same thing. They actually do the same thing. See, they both print out hello, but they're not quite the same thing. This one prints out hello. This one prints out whatever is in S. If I go back over here and change S, that makes a big difference. So now, notice that now 24 and 25 aren't the same thing. Okay. Whenever you need to print out a string, sometimes you just go ahead and print the string. Sometimes you give the string a name. We sometimes refer to this as giving the string a name. Or another way to put it is I'm saying I'm putting the string inside of a variable. So you can say it either way. I've either given the string a name, so its name is S, or you can say I put the string hello there inside of S. This prints S, whatever S is. This always prints hello. Okay, so if I go back to this, then S is hello, so these two print out the same thing, but they're not quite the same thing. More often than not, this is the better way to do it. The better way to do it is to give the string a name and then print it by name, so that later on you could, if you need to change it, suppose I want to print it out twice. Here's here's kind of a dumb example. I want to print hello 3 times. Okay. Okay, so compile, run. Okay, that makes it easy. Now, I could have done the following. Okay, look at lines 23 through 25 and compare them to lines 27 through 29 through 30. Okay, so compare these lines with these lines. Do they do the same thing?
Yes.
If I run it, they sure seem to do the same thing. This one prints hello 3 times, this one prints hello 3 times. But there's something way better about this than about this. From a point of view of learning to program, this guy is way better, even though it does the same thing as these. It's way. Now, can anybody see what's nice about this that's not as nice about this?
You
It's
don't
more
have to type out
streamlined.
hello.
Well, I didn't have to type out hello a bunch of times. That's but something even more important. That here I had to type hello, type hello, type hello. Here I didn't have to type hello all the time.
The quotes.
Pardon me?
The quotes.
The quotes are, I put the quotes here and I put the quotes here, but I didn't have to put them here.
You can use the S variable in any part of your program, and it'll just spit out hello or whatever value is in
be
it.
more precise. Like here, suppose I decided that I want to print out hello there. What do I do here to change it to print out hello there 3 times?
Just change the value of S. All you have to do is say hello there.
Right,
And
just change it once. But what do I have to do here to change it to be a hello there 3 times?
3 times.
I have to make 3 changes. Notice that this says the message is called S. This says print the message 3 times. If I want to change the message, it's real easy. Here I'm saying print the message, print the message, print the message. If I want to change the message, I have to change the message here, change the message here, change the message here. This turns out to be one of the most important ideas in programming. The variable helps me do what's called abstract. The variable says, I hold the message. Now you're going to print the message 3 times. I've separated the actual message from what I do with it. That's good. Here, I'm accomplishing the same thing. I'm printing the message 3 times, but if I want to change the message, I have to go hello there. Then I have to go down here, hello there. Then I have to go down here and say hello there. Okay, and if I goof up, I goof up. Notice that I didn't even type it correctly. So now I can get a bug in my program because I had to make a change so many times that it's real easy to make a little mistake when I make all those changes. Okay, this is considered not good. This is considered way better. This is one of our reasons for using variables. The variable holds an idea, then I can use that idea in my program wherever I want to. So later on, I might use that message again. Later on, I might, after a whole bunch of other code, I might type that message again later on. And this could be hundreds of lines later in my program, but that's still the same message. And if I want to change the message, I just change it in one place. Whereas this one, I have to go and find every place where the message is and change it over and over again. Okay, so that's not good programming. We call this abstraction. I've separated what I want to print from actually printing it. This is what I want to print. Then this one does the printing. Okay. Over here, 3 times I'm saying print this message. Notice, it combines the printing with what I'm printing. The fact that I'm printing and what I'm printing are merged together here. Here, I'm printing whatever's in that message. So up here, I can change the message, okay? So variables are very powerful. Variables let you say, here's a value I want to reuse in my program in different places. So I give my message a name, then I can say, oh, print that message, print that message, print that message. Okay. Now there are lots of reasons for using variables. This is an example of one reason for using variables, so that I could, for example, reuse the string several times. Another good reason for using variables is like doing this, arithmetic. Yeah, quite often we will just do arithmetic with variables. If I want to convert Fahrenheit to Celsius, if I want to look up a day, if I want to calculate a day of a week, a lot of times you'll be using variables to do arithmetic calculations, compute an average, figure out which number's big, figure out which is the larger of 2 numbers. Okay, so variables are for doing arithmetic, but they're also for holding things like holding a message. Okay, now let me show you another thing you can do with variables. Now, clearly you can do arithmetic with numbers. Turns out you can do something like arithmetic with strings too. For example, S is my message. It says hello there. I can add on to that message a little bit more message. Here, the plus symbol has a different meaning here than it did up here. This was the plus of two numbers. Down here, I'm doing the plus of a string with another string. And what it does is it just puts the two strings next to each other. See, so I get there, hello there, class. So I can use variables that are, so you can do arithmetic with string, with integer, within numbers. You can also do something like arithmetic with string variables. You can add them together. Now, I can subtract numbers. Java does not have a subtraction of strings. So, like if I try to compile this, just because Java can add strings doesn't mean it can subtract strings. It can add or subtract numbers. It can't subtract strings. I can also multiply numbers. There is no notion of multiplying strings. The only thing you can do with strings is add them. The we use the word operator. See, if I compile, there's no multiplication of strings. The fancy word we use for a symbol like the plus, minus, we have the plus symbol, the minus symbol, the multiply symbol, the divide symbol. With numbers, I can do any one of those operations. Those symbols are called operators. With strings, the only string operator is plus. There isn't a subtraction, a multiplication, and division for strings, but there is the plus. Okay, so you can take two strings. When you add two strings, it's actually got a name. It's called concatenation. That's a fancy word to mean put next to each other. Okay, and for some reason, programmers like to use fancy words when they can. So when you add two strings, you'll often hear people say you are concatenating the two strings. Okay, a lot of people just say add strings, but a lot of people, if you're reading textbooks about Java or reading about Java, people will often call this concatenating two strings. There's no multiplying or strings or subtracting strings, but there is adding of strings. Okay, notice that means I can take my basic message, hello there, and I can add things to it and make use of it. So I could change what I add to it here. So I could say, hello there, Bob. Suppose I have a Bob in the class. Oh, notice that it didn't print right. Notice I have hello there. Notice, what happened? How do I fix that? Notice that there Bob is all run together. What would I do to fix that?
Add a space before Bob while you have the thing in the quotes.
Yeah, notice that this is kind of tricky. This space here doesn't have any meaning. See this space here between the S and the plus? Notice it doesn't show up in the output. And this space here has no meaning. To get the space in the output, I have to put it inside of the quotes here. I need to put it in there. I need to say quote space Bob. This is kind of tricky. You wouldn't expect that to really work that way. You would think that, oh, when you added two words together, you would automatically get a space between them maybe, but you don't. When you add two strings together, you don't get an automatic space between them. You have to add the space yourself if you want it there. So now I have hello there, Bob. There's all kinds of little tricky things like this when you're doing programming. Things that you might think would be reasonable, like if I'm going to add two strings together, it would put a space between them. It doesn't do very many things automatically for you. You pretty much have to say you want that space there. Okay. You can add as many things as you want. So I could add another thing here. See, So for example, I could add and Jane. Notice I have to put a little space there in front. You can add as many strings as you want together. Notice it comes out as one string. So this is adding my message to the string space Bob and to the string space and Jane, and it's creating one long string here. Okay. Okay. Now the nice thing about here is that whatever this now if I go up here, for example, if I now delete the hello the there, that affects these messages down here now. So down here now I have hello class, hello Bob and Jane. So whatever I put in this string here gets used down here, which is good in many ways. That means I'm reusing this string here in a bunch of different places. Okay, so variables are a good way for you to say, I want to use something over and over again. And I don't want to do it the hard way. This is the bad way to use something over and over again. I want to print out hello there, hello there, hello there. But then if I decide I wanted to change that to hello there, Bob, I'd have to type hello there, Bob. Now, for example, suppose I want to type, here's another good example. Suppose I want to type hello. Suppose I want to type hello there, Bob. Hello there, Jane. And hello there, Alice. Okay, right? Well, down here, I would just say, well, S is hello there. And then here I can say hello there to Bob. Hello there to Jane. And hello there to Alice. Notice I'm reusing down here. A good chunk of what I'm saying is being reused in the S. So now I'm saying, here I'm saying, hello there, Bob, hello there, Jane, hello there, Alice. Okay, that works. Here I'm saying, well, S is the hello there. So that's like the greeting. And then I add on to the greeting, Bob, Jane, and Alice. Okay, and this works. Okay, let's see, I forgot. Alice is missing the space in front of it, okay? Now, but up here, if I want to change the greeting, I have to change it here, here, and here. Down here, I can change my greeting. Oh, I need to capitalize H. Okay, so down here, I make the change once. And I fix a lot of hello there's at once. Okay? So when I've made the greeting a string variable, that's very useful so that if I want to fix something, I fix it once, not fix it over and over and over again. Okay, and if you have a lot of greetings to make, you want to be able to fix things in one place, not in lots of places. So this is giving you an idea of what variables are for. They're for holding values that you would want to use more than one time, so that if you need to make a change in the value, you can change it once and then reuse it over and over again. Okay, and string variables are kind of like numbers. You can add them, but you can't subtract them and multiply them. Okay, so we've got three kinds of variables: integers, doubles, and strings. Okay, so that's our three kinds of variables that we're going to be using for quite a while in the course. We're going to do most of our work with strings, doubles, and strings. There's going to be other kinds of variables. Eventually, we'll learn about several different kinds of variables, but these are our basic ones. Okay, now let me show you. I'm going to take my program I've done here. Oh, I'm going to take this program and I'm going to move it to a website. I want to show you something that we're going to be using a fair amount in this course. Now, we have a bunch of different ways of doing Java. Here we've seen that you can do Java in Dr. Java. Yesterday, I showed you can do Java directly in the textbook. Okay. Then there's a website. We're going to make a lot of use of this. It's called the Java Visualizer. So there's a website called the Java Visualizer, which is another way to do Java programming. Okay, what I'm going to do now is I'm going to take my Dr. Java code and I'm going to copy it and paste it into the Java visualizer. So I'm going to paste it into the Java visualizer. So there's what, there's the code I had in Dr. Java. Now, in Dr. Java, I want to show you the difference between these. It's a real interesting difference. In Dr. Java, when I click run, all the code just happens down here. Okay, so you see the code ran. Okay, and I got all these outputs. Okay, but it all happened at once. The program just runs. Okay, the Java visualizer lets you watch your program run step by step. Okay, so here's what I'm going to do. I've got my code and I click on the visualize button. This is the combination compile run button. Whereas in Dr. Java, I have to compile, then run. In this thing, I just click visualize. What it's doing is it's compiling and now it doesn't run my program. It sets up my program ready to be run. So now what it does is here's my code ready to be run, and I'm going to step through it using a step button. Notice that this button here says forward. It means I'm going to go forward through my code. And let's see. Now in Dr. Java, the output shows up down here. Here's where the output's going to show up. Just like in Dr. Java, the output's going to show up down at the bottom. You can barely see it in the screen. The output's going to show up here. Now watch what happens. I'm going to step through my program. So right now my program's about to do line 3. Okay, my program just did line 3. Now it's about to do line 5. It skipped over the comment. Notice that the hello from line 3 is shown up. Okay, now what does line 5 do? Because now you tell me, how are you supposed to think about line 5?
As an integer?
It does what? It
declares and initializes the variable.
It declares a variable called x. Now, what we really mean that there's some place where the number 3 is being stored in something called x. Okay, so what it's really doing is it's creating a place, and it's giving that place a name, calling it x, and it's saying that in that place is the number 3. Okay, now Java really does all that. Now watch what the Java visualizer is going to do. See over here, it shows me that when I executed line 5, it created a box. The box has got the name x, and in the box is the value 3. That's my variable. And this is really what's happening inside the computer. Inside the computer, you know, when you buy a computer, you're told, oh, buy 8 gigabytes of memory or buy 32 gigabytes of memory. The memory is where these variables are. This is showing you a picture of it, but literally what happened was what Java did is in your computer memory, it took some of the memory and labeled it X and stored the number 3 in it. And the visualizer kind of shows you as a picture that idea that line 5 created a box called X holding 3. Notice I can even go backwards in this program. So here I'm stepping backwards in time. You can go forwards and backwards in time here. Okay, so my program starts off and there's no line 3, there's no variable. It prints out line 3 prints hello. Then I skip line 4 because there's nothing there to do, it's a comment. Then line 5 creates a box for a variable. Okay, what do you think line 6 is going to do?
Same.
Which is what?
Create a value for y.
Well, not a value. It creates a box, a place to hold the value for y. It's actually, the words are kind of weird. The value is what we call the 3.5. So like in this case, 3 is the value, x is the variable. So it like line 5 actually created 2 things. It created the variable and it created the value. So line 6 creates a variable and a value and puts the value in the variable. Okay, so if I do this, you see it actually is doing doing 2 things. It's creating the variable, which is the left hand side, and the value, which is the right hand side, and putting the value in the variable. Okay. Now go to line 7. Now, okay, let me back up a minute. Okay, so now I'm doing line 6. Line 6 created that box. Line 7, what's going to happen when I do, now the yellow box means you're about to do that line. So the gray box means that's the line you just did. So we just did line 6. We're about to do line 7. What's going to happen when I click forward?
Display the quotient in your program output.
Yeah, it'll display whatever 3 divided by 3.5 is. So it's going to print out that quotient. But then it's going to go to, it should go to line 8. But watch what happens. It's going to print out the quotient and it should go to line 8. But look what it did do. It printed the quotient and
to line 9.
It went to line 9. That's because of line 8. Think about it. What did line 8 do?
Initialize the variable.
It didn't initialize it. It did what?
Create it.
It created it, but didn't initialize it. But remember, if you create it and don't initialize it, you can't use it. The visualizer, in a sense, said line 8 really doesn't do anything, so it skipped over it. It really should have shown you a Z with nothing in it. Yeah, what line 8 really did was create a variable Z that actually doesn't have, it's an empty box. So the visualizer skips over line 8. I think it personally, if I was designing this visualizer, I would have had line 8 create a Z with an empty box next to it, because that's what it really did. It created the variable, but did not put anything in it. Now, if I go forward, now it's going to create the Z on over here with 0 in it. Okay, so I think line 8 should have created the Z with an empty box, because that's really what Java did. When I'm about to do line 8 creates the empty box, but the Java visualizer skips over creating the empty box. And then line 9 puts 0 in what was an empty box. So now after line 9 is done, we have Z with a 0 in it. Okay. Oh, is there any difference between an empty box and having a box with 0 in it? This is a philosophical question. What's the difference between an empty box and a box with 0 in it?
The empty box simply doesn't have a value, whereas a box with 0 has a value of 0.
Well, what's the value 0 represent?
A digit.
A digit,
Okay.
yeah. Now, people tend to think of it as representing nothing, but that's actually a mistake. Let me give you a better analogy, a different analogy. What's the difference between having no money and having a bank account with no money in it?
There's like the existence of money, but just a quantity of it equal to 0.
So
Count.
this is like what? If I say, what's the difference between having no money and having a bank account with 0 money in it? This would be like what?
The bank account?
This would be like having no bank account. Notice that there's nothing in it. Actually, it's kind of, if I have a bank account with no money in it, that's different than having no money, because I have a bank account. So there's going to be 2 people. One person has a bank account with no money in it, another person has no money, but no bank account. They're not the same, because one actually has a bank account. In Java, you have kind of a similar analogy. This is literally creating a bank account. This is like having no money, and no bank account. The Z exists, but you can't use it. Oh, it's actually not really a good analogy. When you have a bank account with no money in it, there actually is a number in your bank account. The number is 0. So that would be like this. You know, you have a bank account and it holds 0. Okay. This would be like having a bank account that hasn't been opened yet. You know, it might be like you're in the preliminary stages of creating a bank account. You've created one, but they haven't actually made it available to you. So there isn't even a 0 in it. There just is nothing there. It's kind of weird. People get very mixed up about these kind of things. People tend to think that this is the same as this. Create a variable with nothing in it, but nothing in it would be 0. But in Java, that's not the same thing. Having a variable with nothing in it is not the same thing as having a variable with 0 in it. And most programming languages work this way. This variable is not usable. Remember, we tried to print it. Yeah, if I tried to print the variable before initializing it, if I go back over here, if I do remember this error. You can't print Z without it having something in it. So the Z exists, but it can't be used yet. That's different than the Z has nothing in it, or has 0 in it, and you can print out 0. So this is not allowed. This one's not allowed. Okay? Okay. Right. Now, so start off, print hello, create a variable X with 3 in it, create a variable Y with 3.5 in it. The visualizer skips over creating an empty Z, though there really is an empty Z at this point, but you can't do anything with it. Then the visualizer shows you actually putting 0 in the Z. Now you can print out the 0. Okay. Now I can update the 5. Now remember, what does it mean to put 5 in a double? Y is a decimal number. What happens when you put 5 in a decimal number?
It makes it 5.0.
Yeah, and you'll see that over here. It doesn't really put 5 into the Y, it puts 5.0. Okay, so we see that that's really what's happening. What's being put into Y is 5.0, not 5. Okay, now here's printing out our strings. Hello there, Bob. Hello there, Jane. Hello there, Alice. Now look what Java does here. I want to have a variable S that holds my preface, and then I want to use it over and over again. So here is my variable that holds hello there. So I can reuse that variable as I go through here now. So now when I print this message, it says hello there, Bob. Okay. And when I print the next one, now I get hello there, Jane. And then hello there, Alice. Okay. And if I want to change that, now I can't, one quirky thing about this is you can't edit the code here. This code can't be changed. You have to click on this edit code and go back to this page. If I want to change my message, I would do something like, I could change my message here, okay? And then I go back to visualize, and then I can step forward through my code. And now I see that, oh, my variable now holds hello there with a capital T. Okay, so now it uses that variable in the outputs. Okay. Oh, and what happened? There was a Bob was missing a space. Notice I can't fix that here. See, Bob is missing a space in front of it. You can't fix that here. You can't change things in this version of the visualizer. If you want to fix something, you have to go back to edit code. You have to fix it there. Then click on visualize, and then you see your fix. Okay, so there's my fixed code. Okay, the visualizer lets you, it does two things for you. It lets you watch your program execute step by step, and it shows you on the right-hand side all your variables. It gives you a picture of what your variables look like at any given time, which is tremendously useful when you're trying to figure out what programs do, and as you're trying to learn how programs work. Watching the variables change is a very good thing to do. It's a very useful thing to be doing. Also, you can stretch this screen this way so you can see your code better. You can't change things up and down. To change things up and down, you scroll like this. You can't make this window grow vertically. But you can make it grow horizontally. Okay. You can scroll it up and down to see code. And the same thing, and you can scroll this whole window up and down to see the output. Okay. So the Java visualizer is our way to visualize how a program is running. It lets us see the variables. Now, if you go back to the textbook in this section on variables talks about memory diagrams. This picture here is showing you what the Java visualizer. This is the memory diagram. The Java visualizer is what draws the memory diagrams that the book is talking about. Okay? And that's what the Java visualizer was designed for. It's a place where you could see the memory. See, here the book just made a picture. They just drew a memory diagram down here. When you write int a equals 5, you create this int called a that holds. Well, here, see, they said int a equals 5. Actually, let's take this code here and put it in the Java visualizer. Notice that let's step through this code in our mind. What does int a equal 5 do?
Sets the value to 5 for a.
Well, it does more than sets the value. It creates the a, then puts 5 in it, right? So it creates the a and puts 5 in it. What does this line of code do?
It creates b and gives it the same value as a.
Yeah, it creates the b and then puts in it a copy of what was in a. Then what does this line do?
Changes the value of a to 3.
Okay, now this picture is what memory looks like after all 3 of those lines are done. But it doesn't show you those 3 lines as they're executing. So let's take this code and put it into Java Visualizer. So I'm going to copy this over to the Java Visualizer. So I'm going to open a new Java Visualizer window. So I'm going to open, you can have as many Java Visualizer windows open as you want. So you can be working with more than one piece of code. So there's their code. Okay, there's their 3 lines of code. Now, let me visualize their 3 lines of code. The nice thing about the Java Visualizer is I get to watch the code happen. So first, I create the A with 5 in it. That's my starting point. Then I create the B and copy what was in A into B. Then the 3rd line puts 3 in A. Notice that this picture here now is where the book was. So this picture here is what you saw after all 3 of these lines were executed. The beauty of the Java Visualizer is you can go backwards and forwards and see, well, how did I get to that picture? Well, I started with nothing in memory. Then I create A holding 5, create B holding a copy of A. Notice that B and A are not, this is a little bit tricky. This is not saying that B and A are the same forever. It's really saying you're copying A into B, so B is equal to A for a moment. But then as soon as you change A, B and A are no longer equal to each other. That's actually kind of important. You have to take this with a grain of salt. It's saying that B equals A at this moment. It's not saying that B equals A forever, from now on. So, because if it meant B equals A forever, suppose this meant that B and A are the same forever, then what would this do? Suppose you took this literally to mean that B and A are the same thing.
It would also make B 3.
Yeah, then now there are programming languages that work that way. There are programming languages that would work that way, that this would mean B and A are the same thing from now on. So if you change A, you change B. Java doesn't work that way, but there are programming languages that work that way because it does sound reasonable. A is 5, B is A. So from now on, B and A are the same thing. Change A, so you change B too. Java doesn't work that way, but there are languages that do. Okay, because what a programming language does is entirely up to the people who invented the language. When you read something like this, notice it doesn't really tell you what it does. When you say B equals A, you don't really know what someone means by that. In some programming language, it means copy A into B so that at least for now, they hold the same value. That's what Java does. Other languages do mean B and A are the same thing. They are equal. So anything you do to A, you're doing to B, and anything you do to B, you're doing to A. That's not very common, but there's a small number of programming languages that work that way. When you say B equals A, you're saying these two variables are the same from now on. The point is that what a language does with these commands is entirely up to the people who design the language. It's not clear what B equals A really means. So what it means to me can mean different than what it means to you. Now, from our point of view, it means whatever Java says it means. So as we learn Java, we have to learn what Java means by B equals A. What Java means is that you copy the value from A, so you go backwards. What B equals A means is you're going to create a B and copy whatever's in A into B. But they're not the same thing. So there's an A box and a B box. So it's not saying that A and B are the same thing. They have their own boxes. They just happen to, at this point, hold the same value. And then if you want, you can go immediately change A. So now they're not the same. Okay. So now this picture is what the book was showing here, but this is the picture at the end of this code. This book doesn't show you how the code was stepping through. Okay, we've actually reached the end of class, right? We're at the end of class time. So we've talked, we've got a good introduction to what variables are. Like this code that what I'm going to do is this example we did in class here, I'm going to put it up on the website. I can create a link to this now. I'll show you, well, actually, I'll show you real quick how I do it. I click on generate URL, then I go down here and I copy that. And now I can do things like I can just open a new page and say, oh, look, there's my code. And I'll create a link to it. So you'll be able to go back to this example and play around with it. I'll make it part of the course website. So that's kind of a nice feature of the Java Visualizer. You can type some code into it, and then you can generate a URL to it, which you can send to people, or in that case, I'll put it in the course website. So you'll be able to go back and look at this example and play around with it. Okay, if you've got, I'm going to end the meeting here. Let's see, actually, I want to make sure I save this. Oh, I can save it, yeah. I'm going to stop sharing, and I'm going to end the meeting. If you've got any questions, anything that came up while we were talking about all this stuff, please just send me an email. Like I say, I'm going to put a link to this example up on the course website. If you want to go back and look at it and play around with it, you'll be able to. If you want to, and I'll put a link to this video up on the course website also. Anybody got any last minute question?
How do you get the line numbers on Java again?
Oh, yeah. Oh, yeah. Let's do that again real quick. You do that with the edit preferences, then you go to display options. So edit preferences, display options, and then there's a little checkbox.
All right, thank you.
Yeah, and everybody do that. You only need to do it once. Once you've done it, Dr. Java will remember that you've done it, and it'll come up with line numbers. And line numbers are really, notice that the Java Visualizer uses line numbers. It's actually kind of bizarre that Dr. Java doesn't have line numbers turned on automatically. It's just kind of weird that they don't turn it on automatically. So everybody should turn on line numbers in their Dr. Java. You'll really need them. Okay. Any other last minute question? Any last minute question? Okay. So I'm going to stop sharing. And I'm going to go ahead and end the meeting. And again, there'll be a video up for this on the there'll be a link to the video up on the website soon, and I'll put a link to that piece of code that we looked at. And if you have any questions, please write to me. Okay. See you on Monday. Bye-bye.
Have a nice day.